So next question, find the eigenvalues and eigenvectors of A is equal to 2, 2, 0, 2, 1, 1, minus 7, 2, minus 3. So this is a 3 by 3 matrix. A is of 3 by 3 matrix. So the characteristic equation will be a cubic equation, that is degree 3 വരുന്ന equation. That is lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. And what is s1, s2 and s3? S1 is sum of the diagonal elements, that is 2 plus 1 plus minus 3, that is 0. S2 is sum of the minors of the diagonal elements. Minor means delete the row and column containing this particular element and find the subdeterminant value. So it is 2 in the minor, 2 and 2 contains in the row column, delete 1, 1, 2 minus 3. Then next one 1. So delete the row and column containing this one. So 2, 0, minus 7, minus 3. And minus 3, it is 2, 2, 2, 1. And the sum is minus 30. Okay. Then what is S3? S3 is determinant of A. That is minus 12. Then substituting lambda cube plus 0 lambda square minus 13 lambda plus 12 0. Or it is lambda cube minus 13 lambda plus 12 0. So this is a cubic equation. What is the values for lambda? So you can use the calculator. Okay. Substitute the coefficients of these terms. We get the values directly from the calculator. Or without calculator also we can find this value using this method. That is the division method. First of all, find any one of the values of lambda by trial and error method. So if you put lambda is equal to 1, check for lambda 1, minus 1, minus 2, etc. Okay, so if lambda is 1, it is 1 minus 13 plus 12, it is 0. So lambda is equal to 1 is a root. Then divide this polynomial by lambda minus 1, because if lambda is equal to 1 is a root, lambda minus 1 will be a factor. So dividing by this term, so writing the coefficients, then lambda is equal to 1, then add 1 plus 0, 1, 1 into 1, 1, add 0 plus 1 is 1, 1 into 1, 1, then minus 3, minus 13 plus 1, minus 12, then minus 12 into 1, minus 12, adding 0. So last term is the remainder. Since it is the factor, remainder is 0. So next we get the coefficients 1, 1, minus 12 as a coefficients for a second degree polynomial, because it is third degree. If we divide it by first degree polynomial, we get second degree. Okay. So it is lambda square plus lambda minus 12 is equal to 0. And again solving this quadratic equation, that you know, factorization or using minus b plus or minus root of b square minus 4ac by 2a. So the product minus 12, sum plus 1. So it is plus 4 and minus 3. So lambda plus 4 to lambda minus 3 is equal to 0. Lambda is minus 4 and 3. So the values of lambda 1, minus 4 and 3. Okay. So first we find the eigenvalues, then next step is to find the eigenvector. If lambda is equal to 1, that is a minus lambda into x is equal to 0. This homogeneous equation substitute. If for lambda is equal to 1 means subtract 1 from the diagonal elements. So 2 minus 1, 1 minus 1, minus 3 minus 1. Then the vector is x1, x2, x3 is equal to 0. Then what is the eigenvector? We can use this method to find the eigenvectors. That is, choose any two rows of this matrix. Choose any two rows. Okay, so here I choose first and second. Then x1 by ഈ x1 മാറ്റിയിട്ട് പിന്നെയുള്ള രണ്ടെണ്ണം. Okay, second and third, consider this one, x1 by this matrix determinant 2, 0, 0, 1. Then minus x2, that is the signed, that is cofactor, minus x2 by x2 second column, so delete that column. So 1, 0, 2, 1, 1, 0, 2, 1, first and last. Then is equal to x3, third one by third one, kalanyale 1, 2, 2, 0. Okay, x1 by second and third columns, x2 by first and third, then x3 by first and second. Okay, so this is x1 by 2 minus x2 by 1, x3 by minus 4, or it is x1 by 2 is equal to, this is minus x2, so this minus can be taken to the denominator. So x2 by minus 1, x3 by minus 4. So the denominator, we get the denominators as the eigenvector. Denominator is 2 minus 1 minus 4. So this is the eigenvector for corresponding to lambda is equal to 1. Okay, if there is a common term, we can divide by that common term also, because infinite number of eigenvectors are there. Okay, so next is lambda is equal to minus 4. If lambda is minus 4, a minus lambda into x is equal to 0. This implies subtract minus 4 from the diagonals, that is adding plus 4. So similarly, we can choose the first and second rows. x1 by what? 2051 minus x2 by 6021, x3 by 6225, that is 2 minus 6 26. Or we can divide by 2 common. Okay, 2 is the common factor, so it is 1 minus 3 13. This is the second eigenvector. Then lambda is equal to 3. Subtract 3 from the diagonals, x1 x2 x2 0. So here also choosing the first two rows. So x1 by 2 0 minus 2 1 minus x2 by minus 1 0 2 1, x3 by minus 1 2 2 minus 2, that is 2 1 minus 2. This is the third eigenvector. Okay.